In this example, we have the function f of x in the form of x divided by x minus 2. We're going to find all values of x where the derivative is 0 and also determine the function, the interval that the function increasing, decreasing. The derivative is 0 or where the horizontal tangent occurs. So in part A, we're going to find the f prime of x. And then next, we're going to solve for x where the f prime of x equals 0. And after that, in part B, we're going to use the real number line for the sign of the derivative. The plus sign means increasing. The minus sign means decreasing. So starting from part A, since the f of x is x over x minus 2, we're going to find f prime. Recall when you have the rational form or the quotient form. This is the quotient form. So we're going to identify the top as the high expression and the bottom as a low expression. The formula to find the derivative of the quotient form or the quotient rule is low d high minus high d low. Draw the line, low squared. And our case, the high is x, the low is x minus 2. The d high, which is the derivative of the h, or 1. The d low is the derivative of x minus 2 or 1, which is the same as the d high. And then we just replace the values into the formula for the quotient rule. The low, which is the quantity x minus 2, multiplied by d high, which is 1, minus high, which is the x, multiplied by d low, which is the 1, all divided by the low square, which is the quantity x minus 2 squared. Simplify as much as we can. The numerator that give us the x minus 2 minus x minus x. So x and minus x cancel out. Therefore, we have the numerator as negative 2 divided by the quantity x minus 2 squared. And this is the f prime. And we have the f prime in the fraction form. We're going to solve for x next, where the f prime equals 0. With the expression we have, negative 2 divided by x minus 2 quantity squared equals 0. When you cross multiply, it becomes a negative 2 equals 0, which is not true. Therefore, for this problem, therefore, there is no x such that the f prime of x equals 0. So then the graph will not provide you any point that the horizontal tangent will occur. Now we're going to find out the interval that the graph increasing or decreasing in part B, as you use the derivative to determine the interval of increasing, decreasing. If the derivative positive, the graph increasing, derivative negative, the graph decreasing. From what we have, the f prime is negative 2 divided by the quantity minus 2 squared. For the domain, let's see what is the domain of this problem. So the domain domain of the function, since the function is in the form of x divided by x minus 2, that means x cannot be 2. X cannot be 2. So we're going to use the real number line to represent the f prime, and the point that it cannot have the graph or the graph is not defined would be the point x equals positive 2. So at this point where x equals 2, no graph, so I draw the dotted line on the right side of the x equals 2. For example, for x greater than 2, what would be the sign of the f prime? So the f prime equals negative 2 divided by the quantity x minus 2 squared. The square gonna give you positive no matter what. And then the numerator negative 2, which is fixed to be negative 2, is no change. So then the sign on the right hand side remain negative in sign. And similar to the value, any value x less than 2, the f prime, which is the same formula or the same expression as negative 2 divided by x minus 2 squared. The square term always positive, but the negative 2 remain negative because it's fixed to be negative 2. Same situation, the left and the right side of the number 2. So the slope of the graph gonna be negative. Therefore, in this case, the graph will be decreasing for both sides of the line x equals 2. So we can make a summary on the bottom here as the function f of x. The function f of x is decreasing in the interval. The left hand side is negative infinity to the positive 2 and also 2 to infinity. We do not include 2 because at 2 the function not defined. So make a note. At x equals 2, f of x is not defined. So that's why 2 is the breaking point of the graph.